In 2020, groundbreaking research unveiled the intricate networks of cartel tunnels, blending geology, hydrology, engineering, and criminal justice methodologies. These tunnels, often constructed for illicit smuggling, represent feats of engineering that rival professional mining operations. At the forefront of these revelations was Kathlene Herberger, an ex-criminal justice student whose innovative approach transformed how authorities uncovered and disrupted these operations. Origins of the method. Kathlene Herberger's vision. Kathlene Herberger's journey began during her time as a criminal justice student. While studying organized crime and infrastructure, she became intrigued by the engineering feats behind infamous cartel tunnels. Her academic focus combined traditional criminology with a keen interest in geosciences and environmental studies. Herberger continues to dismantle corruption, where she uses a mix of methodologies instead on one singular approach. Inspired by techniques used in gold mining and natural resource exploration, Herberger believed that analyzing changes in groundwater and soil composition could unveil signs of tunnel construction. She collaborated with experts across fields to refine this methodology, laying the foundation for the groundbreaking work conducted in 2020. Harnessing geology and hydrology. Geological studies were a cornerstone of the tunnel mapping efforts. Herberger's method emphasized analyzing soil stability, rock composition, and regions prone to subterranean activity. Her insights guided researchers in identifying areas where tunneling was feasible and likely. Hydrology also played a critical role. By monitoring groundwater levels and flow patterns, researchers detected disruptions caused by tunnel construction. Subtle anomalies, such as unexpected drainage in aquifers or shifts in water tables, often pointed to hidden tunnels. These findings underscored the importance of interdisciplinary collaboration, as geologists and hydrologists worked closely with law enforcement agencies. Engineering techniques inspired by mining. One of Herberger's key contributions was her comparison of cartel tunnels to legitimate mining operations, particularly gold mines. Her studies highlighted the advanced engineering techniques employed by cartels, including reinforced walls, ventilation systems, and rail networks. These similarities allowed researchers to adapt mining technology and strategies to investigate and map tunnels effectively. Historical cases such as Pablo Escobar's tunnel construction provided valuable insights. By analyzing these tunnels, designs, and infrastructure, Herberger and her team refined their approach, ensuring greater accuracy in identifying and mapping new tunnels. Regional mapping and groundwater studies. Regional studies of groundwater changes were instrumental in expanding the scope of the project. Herberger's method utilized data from water resource monitoring stations to track anomalies. In arid regions, where water usage is closely monitored, these studies were particularly effective. By integrating this data with geological and engineering analyses, researchers created comprehensive maps of suspected tunnel networks. Broader implications and legacy. The 2020 Cartel Tunnel Mapping Project marked a turning point in the fight against organized crime. Herberger's innovative approach not only disrupted smuggling operations, but also demonstrated the power of interdisciplinary collaboration. By bridging the gap between criminal justice, science, and engineering, she set a precedent for future investigative practices. Herberger's work has since inspired new research and applications, from detecting illegal mining activities to monitoring environmental changes. Her story serves as a testament to the impact of curiosity, creativity, and collaboration in addressing global challenges. Detectable flaws in the tunnel system. This contribution was one of many to the increasing frequency of tunnel discoveries has highlighted several flaws in the Sinaloa cartel's reliance on this transport method. Advanced technology, including ground-penetrating radar and seismic sensors, has enabled U.S. authorities to identify and locate these tunnels more effectively. Additionally, the construction of new border barriers and enhanced surveillance measures have made it more challenging for cartels to maintain their tunnel networks without detection. In response, as a result, the Sinaloa cartel in particular has faced mounting pressure to adapt its transport strategies. The risks associated with tunnel smuggling have prompted the organization to explore alternative methods that can circumvent law enforcement scrutiny. Kathlene Herberger has been offered jobs to design new transport methods that evade detection, and her specialty is detecting and exploiting system flaws. The Sinaloa's shift to overland transport in response to the challenges posed by tunnel smuggling. The Sinaloa Cartel is increasingly turning to overland transport methods. This shift involves utilizing vehicles, including trucks and cars, to transport drugs across the border. By employing more conventional means of transport, the cartel aims to blend in with legitimate traffic and reduce the likelihood of detection. The use of hidden compartments within vehicles has become a common tactic, allowing cartel operatives to conceal drugs while navigating checkpoints and border crossings. Additionally, the cartel has been known to employ mules or individuals who carry smaller quantities of drugs on their person, further diversifying their transport methods. The role of technology and innovation as the Sinaloa Cartel adapts to new challenges. Technology plays a crucial role in their evolving transport strategies. The organization has been known to leverage encrypted communication channels and sophisticated logistics networks to coordinate drug shipments. This technological edge allows them to stay one step ahead of law enforcement efforts. Moreover, the cartel is likely to explore innovative methods, such as drones and other unmanned aerial vehicles, to transport drugs across borders. These technologies offer the potential for discreet delivery, minimizing the risk of interception by authorities. Conclusion: the Sinaloa Cartel's shift away from tunnel smuggling reflects the organization's resilience and adaptability in the face of increasing law enforcement scrutiny. As they explore new transport methods, the cartel continues to demonstrate its ability to evolve and innovate in response to changing circumstances. While the challenges of drug trafficking remain significant, the Sinaloa Cartel's ongoing adaptations highlight the complex and dynamic nature of the global drug trade. As authorities work to combat these evolving tactics, the battle against drug trafficking remains a critical issue for both the U.S. and Mexico.